Hi, my name is I-Chen who come from Kaohsiung, Taiwan. I would like to present our research, some result about our research. The title is Integration of IoT and BIM Technology to Improve Information System for Fire Rescue and Escape. It's okay. Structure fire are common urban disaster. Generally, the people involved into the fire can classify into two groups, evacuees and firefighters. The main reason why most evacuees die at fire is later they have a poor sense of the escape, encounter the obstacle of the evacuation. On the other hand, the firefighter often enter the fire scenes merely based on land past experience without foreknowledge of a location or spatial configuration. Summarize the above, the most dangerous condition in a fire scene for both groups of people are. First one, lack of information about fire scenes and spatial configuration causing incorrect decision making when choosing the escape route. The ambiguity of change in the fire scenes, which can cause the occupants to spend too much time trying to escape. Based on above mentioned reasons, this research integrates three major research fields: BIM, fire simulation, and IoT technology to develop a structured fire visualization and warning system. This system can provide useful information to firefighters such that they can be aware of the fire scene's environment and create an effective rescue plan. The automatic LED escape route point could assist the building occupants to escape and allow them to discover the hazards in time, so that the number of casualties could be minimized. This slide shows the system frame work. Period to the fire, it is possible to simulate the different fire scenarios by using FDS and visualize the results in a BIM model. This allows users to understand the possible hazards and the situation that may occur in the environment during a fire. In the event of structural fire, we can use IoT technology to retain the real-time conditions and present them in a BIM model, while providing a visual representation of the environment and warning function for evaluation in rescue planning. In addition, the system can control the LED guide point according to the real-time situation to assist the occupants to escape, reducing the number of casualties. This research uses BIM model as its foundation and also use as the input source of fire disaster simulation. Reobtaining and reconstructing the data do not consume a huge amount of time and labor. And then set up the position of fire source and the simulation parameter according to different scenarios. The simulation results and the time are returned in a case database from which the firefighters can retrieve a case similar to the current situation. The results of case obtained from the simulation are translated into BIM model and can be visualized in various ways, such like a 1D test, 2D diagram, and a 3D model as a rescue basis for the firefighters. This research also integrates an IoT framework to propose a smarter escape alert function. Environment sensor gather the building's physical factors, and then these physical factors are used to control LED guide pointer to present danger alerts and evacuation guidance. Example, the setting of this research was the Department of Civil Engineering at National Kaohsiung University of Science and Technology. This is our building. A BIM model of a 7-story building with a basement as construction with Autodesk Revit for testing purpose, as shown in the figure A. This research uses PyroSim software to perform the fire disaster simulation, as shown in figure B. The case choose are the research laboratory on the 2nd floor, computer room on the 3rd floor, and the material laboratory on the 5th floor. This slide shows the graphic user interface about the structure fire visualization and the warning system. This system was constructed in Autodesk Revit, and Microsoft .NET C# was used to develop the API. In the process of using PyroSim to simulate the fire, this research placed a device 2 meters in height between each 4 closed floor mesh. This device collects output value from the structural fire simulation and creates a data report for future use in data visualization. Figure presents the mapping of the location of the device to UV coordinates in the BIM model. These points provide the simulation result value for data visualization. There are 2 ways to display data, color surface and marker with text in Autodesk Revit. This research employs a color surface with a gradient effect for display, as shown in the figure. Fire simulation will generate data such as temperature, CO, and the loss of visibility caused by smoke. This simulation results are shown in the following slide. First one is a simulation result about the temperature, 2nd floor, 3rd floor, and 5th floor. The second picture shows the simulation result about the CO. The third one shows the simulation result about the loss of the visualization caused by smoke. Final one is this research uses the BIM model as its foundation, so user can control the view later they want to see. This research utilizes the Revit API to allow the database to connect with the detector and return the result to the BIM model. When the detector detects a rise in temperature or a flame, this system will send out alarms and point out the position of the abnormality as shown in the figure. Firefighter also can evaluate the trade of the fire and control the LED guide point based on the simulation result and environmental monitoring data. Take example, when a flame is detected, the door element in the BIM model will shine and display the warning, and the system will automatically switch the LED pointer to no entry in order to prevent the evacuation accident opening the door of the emergency exit, which may create more casualties. Conclusions. This research mainly solves the data integration problem of FDS, BIM, and IoT, and it provides accurate real-time data to the firefighters. This eliminates the lack of information inherent to traditional fire rescue, which can lead to casualties. Furthermore, automatic guide points that provide correct instruction according to the simulation results of the life situation may reduce the number of casualties due to the panic. Thank you.